This video is all about the summary of Module 12. A wireless LAN is a type of wireless network that is commonly used in homes, office, and campus environments. Wireless networks are based on IEEE standards and can be classified into four main parts: WPAN, WLAN, WMAN, and last, W1. Wireless LAN technologies uses the unlicensed radio spectrum to send and receive data. Examples of this technology are Bluetooth, WiMAX, cellular broadband, and satellite broadband. The IEEE 802.11 WLAN standards define how radio frequencies are used for wireless links. WLAN networks operate in the 2.4 GHz frequency band, and the 5 GHz band standards ensure interoperability between devices that are made by different manufacturers internationally. The three organizations influencing WLAN standards are the ITUR and IEEE and the Wi-Fi Alliance. To communicate wirelessly, most devices include integrated wireless NICs that incorporate a radio transmitter or receiver. The wireless router serves as an access point, a switch, and a router. Wireless clients use their wireless NIC to discover nearby APs advertising their SSID. Clients then attempt to associate and authenticate with an AP. After being authenticated, wireless users have access to the network resources. APs can be categorized as either autonomous APs or controller-based APs. There are three types of antennas for business class APs. First is the omnidirectional, the second one is directional, and last, the MIMO. The 802.11 standard identifies two main wireless topology modes: ad hoc mode and infrastructure mode. Tethering is used to provide quick wireless access. In infrastructure mode defines two topology building blocks: a basic service set or BSS and an extended service set or ESS. All 802.11 wireless frames contain the following field: frame control, duration, address 1, address 2, address 3, sequence control, address 4, payload, and FCS. WLANs use CSMA-CA as the method to determine how and when to send data on the network. Part of the 802.11 process is discovering a WLAN and subsequently connecting to it. Wireless device discover a wireless AP, authenticate with it, and then associate with it. Wireless clients connect to the AP using a scanning process which may be passive or active. CAPWAP is an IEEE standard protocol that enables a WLC to manage multiple APs and WLANs. The CAPWAP split concept does all of the function normally performed by individual APs and distributes them between two functional components. AP-MAC functions, and WLC-MAC functions. DTLS is a protocol which provides security between the AP and the WLC. Flex Connect is a wireless solution for branch office and remote office deployments. You configure a control access points in a branch office from the corporate office through a WAN link. Without deploying a controller in each office, there are two modes of operation for the Flex Connect AP. First is the connected and the second one is the standalone. Wireless LAN devices have transmitters and receivers tuned to specific frequencies of radio waves to communicate. Frequencies are allocated as ranges. Ranges are then split into smaller ranges called channels. The example of channels is DSSS, FHSS, and last OFDM. The H02.11 B-G-N standards operate in the 2.4 GHz to 2.5 GHz spectrum. The 2.4 GHz band is subdivided into multiple channels. Each channel is allotted 22 MHz bandwidth and is separated from the next channel by 5 MHz. When planning the location of APs, the approximate circular coverage area is important. Wireless networks are susceptible to threats, including data interception, wireless intruders, DOS attacks, and rogue APs. Wireless DOS attacks can be the result of improperly configured device, a malicious user internationally interfering with the wireless communication, and accidental interference. A rogue AP is an AP or wireless router that has been connected to corporate network without explicit authorization. When connected, a threat actor can use the rogue AP to capture MAC addresses, capture the data packets, gain access to networks resources, or launch a MITM attack. In a MITM attack, the threat actor is positioned in between two legitimate entities to read or modify the data that passes between the two parties. A popular wireless MITM attack is called the Evil Twin AP attack, where a threat actor introduces a rogue AP and configures it with the same SSID as a legitimate AP. To prevent the installation of rogue APs, organizations must configure WLC with rogue AP policies. To keep wireless intruders out and protect data, two early security features are still available on most routers and APs: SSID clocking and MAC address filtering. There are 4 shared key authentication techniques available. First is the WEP, the second one is the WPA, third is WPA2, and last, the WPA3. Devices with WPA3 are not yet readily available. Home routers typically have two choices for authentication: WPA and WPA2. WPA2 is the stronger of two. Encryption is used to protect data. The WPA and WPA2 standards use the following encryption protocols. First is TKIP and the second one is AES. In networks that have stricter security requirements, An additional authentication or login is required to grant wireless clients access. The enterprise security mode choice requires an authentication, authorization, and accounting, or AAA, radio server. So guys, that's all for the summary of Module 12.